So for this question, we're given that f of x is cos 3x. We want to determine f prime of x and f double prime of x. And our concept here is the chain rule. So let me remind you of the basic ideas here. One notion is that dy dx equals dy du times du dx. So that's one way of looking at the chain rule. So in this case, let's go ahead and change f of x to y. If I say y equals cos 3x, then my goal is to find the derivative, which would be to find dy dx. I need to substitute a u. So u is the inner function. U, the inner function being 3x. So u is 3x. So the derivative of u with respect to x is 3. Well, if u is 3x, y then is cos u. So what is dy du? It's the derivative with respect to u of cos u, which of course is just negative sine u. So f prime of x is the same concept as dy dx, which will be dy du times du dx, which gives me what? Dy du, we said was negative sine u, times du dx. Du dx is 3. So we get negative 3 sine u, but that's not really my answer. My final answer needs to be in terms of x. So making the substitution, what are we going to say? F prime of x, which equals dy dx, will equal negative 3 sine u, or if you prefer, f prime of x is negative 3 times the sine of u, u being 3x. So that's one approach to the chain rule. That approach being that dy dx is dy du times du dx. But there's another way that we can do this. So let's take a look at it. So we're saying f of x is cosine 3x. How do we take the derivative using the chain rule? Using an alternative strategy. So f prime of x, just make sure we're clear on our notation, is the derivative of the cosine of 3x. So what is the derivative of the cosine of something? The derivative of the cosine of something is minus the sine of the something times the derivative of the something. So our something here, which is essentially our u that we just did in the previous version of this, minus sine of 3x times the derivative with respect to x of 3x, and we get f prime of x is minus sine 3x times 3, so that f prime of x is minus 3 sine 3x. And then our next strategy was to do what? Was to find the second derivative. So what does the second derivative mean? F prime prime of x is the derivative with respect to x of f prime of x, which is the derivative with respect to x of negative 3 sine 3x. And what can we do here? Well, you can pull this negative 3 out in front. It is a constant. It moves in front of the derivative operator. And we have f double prime of x equals negative 3 times the derivative of sine 3x. And there's a couple ways we could do this. We could do this with u's. We could do this with the inside-outside function, whatever you prefer. I think I'm going to go ahead and just use the inside-outside approach. So we'll say that f double prime of x is negative 3 times. What's the derivative of the sine of something? The derivative of the sine of something is the cosine of something times the derivative with respect to x of the something. And what is my something here? My something is 3x. So we'll replace this with derivative of sine of something is cos of something, derivative of the something, cos 3x times the derivative of 3x. And where does that leave me? Then I have f double prime of x is negative 3 cos 3x times what? Times 3. And then what do we finish with? Negative 3 times 3 is negative 9 cos 3x. So we started with the function f of x, and then we had a function, the derivative of f of x, and then we had a function, the second derivative of f of x. Let us look at all of those and try to check them as best we can. So our original question was f of x is cos 3x. Using the chain rule, we believe that f prime of x is negative 3 sine 3x. And we believe f double prime of x is negative 9 cos 3x. And I want to check these, and I'm going to use Desmos. And remember, of course, that our formal definition, f prime of x, is the limit as h goes to 0 of f of x plus h minus f of x over h. And I'd like to see if my answer here is correct. So I'm going to pull up Desmos, and I'm going to plug in those various values. I'm going to plug in my function for f, and I'm going to use a very small value for h, maybe an h value of 0.001 or something to that extent. So let's go ahead and pull up Desmos. So we're here. And I want to go ahead and put in my original function f of x equals cosine of 3x. And we see the function looks like that. I could adjust the window if I would like, but I think that's probably going to be good enough. And now I want to graph its derivative, so I'm going to turn this off for a minute, and its derivative will be approximately f of x plus a small number, our h 0.001, minus f of x divided by 0.001. This should be our approximation for the derivative. So that was my original function is in red. Its derivative is now in blue. Let me turn that off. What do I think f prime is? And I'm going to call that g. I think f prime is, what did we show previously? We thought f prime was negative 3 sine 3x. Let's take a look at that. So is that correct? Negative 3 sine 3x. Does that match? So that's the function in green. The function in blue is the f of x plus h minus f of x over h with a small h version. Do the blue and the green functions match? They seem to. So that looks pretty good. All right. So now here's my first derivative. Negative 3 sine 3x. What is the derivative of that? So we'll again play with our h game and say g of x plus 0.001 minus g of x divided by 0.001. And I might need to go with a smaller h, but we'll try this and see if this works. So this purple function is what I believe is the derivative of the derivative. Kind of hard to see that. Let's adjust the window a little bit. Going to get a lot more y, and maybe negative 20 to 20. Just so I can see how it's behaving. Okay. And then I want to see if what I believe the second derivative is matches this purple function. What did I think the second derivative was? I thought it was negative 9 cos 3x. Let's see if it is. Turn this purple function off. Call it k of x. Because what we think is the derivative is negative 9 cos 3x. Does it match? Does the black function match the purple function we had before? It looks like it does. And that should do it for us.